Okay, this is a short introduction to how the brain learns. Basically, once sensory information enters in through your eyes, your ears, or anything, it's routed to your brainstem. Your brainstem sends that information to the thalamus. The thalamus is part of the limbic system. And we're just going to keep rolling. The limbic system is responsible for regulating the body and basically filtering all the sensory information. It's a filter. Once the thalamus gets the information, it sends it to all the other parts of the brain, depending on what kind of information is coming in. Okay, so these are the different parts of your brain: the frontal, parietal, temporal, occipital, cerebellum, and brainstem. So the thalamus and the limbic system are kind of in the middle of your brain, behind the temporal lobe. So each one of these parts of the brain is in charge of a different function. So occipital is like your eyes, things that you see. So this is where visual memories are formed. This is like motor or spatial information is stored. The frontal is judgment. This is the one that really affects a lot of our students because their judgment isn't fully developed until the age of 25. And then this is more of language processing, so speech. Or words and text. And then the cerebellum and movement. So you can see you've got like all of your different ways that people learn right here in the different cortexes of your brain. So if you're a visual learner, those memories are stored here. Spatial or kinesthetic would be in the cerebellum. So once information is routed to the different parts of the brain, that's where neurons start connecting to form memories. Now, at birth, the brain is thought to have more than 100 billion neurons. They're actually very different from other cells because they can communicate with each other, which is what I'm going to show you. They have a cell body, which this part is here. And then each neuron also has a tail-like extension called an axon. And these parts that stick out are called dendrites. So all of these different parts here are dendrites. And each neuron is thought to have between 6,000 and 10,000 dendrites to make connections with. Each neuron also communicates with each other electrochemically, so that's what's starting to happen here. When learning takes place, the neurons or the dendrites start moving towards each other to connect. So here is where something called synaptic adhesion is taking place. So the dendrites reach out to each other and they start communicating. So this is a dendrite. Electrochemically, and this is symbolizing the electric chemicals feeding information back and forth between the dendrites. So our electrochemicals are things like serotonin, melatonin, endorphins, and whatnot. They're all brain chemicals that are very much impacted by the way we live our lives every day. So things such as sleep, nutrition, and exercise really affect our serotonin levels, our melatonin, and endorphins. And unfortunately, these are also things that we can't control as much with our students. But what we can control as teachers are the ways we teach our different learning styles. So it comes back to the cortexes again. If we teach to our visual learners, our kinesthetic learners, our auditory learners, the more ways we choose to teach the information and the more opportunities they have to learn it different ways, and this goes back to Howard Gardner's theory of multiple intelligences, the more connections they're starting to make in their brain. So once these dendrites start to connect, it creates synaptic adhesion, and that's what really starts to form the memories. And eventually the memory that forms with the learning will be stored in long-term memory rather than at the neurological connection. So this is why technology is so important to our students' learning, because it engages the brain and allows us to teach to all our different learning preferences.